You're listening to Make Me Data Literate from the Australian Data Science Education Institute. I'm your host, Dr. Linda McIver, author of Raising Heretics, Teaching Kids to Change the World. Let's go change your mind about data. Thank you for joining us for another episode of Make Me Data Literate. Very excited for our guest today. Again, we're changing tack and looking at some new and interesting stuff that we haven't covered before. So welcome, Fiona. Who are you and what do you do?
Well, thank you very much for having me, Linda. My name is Fiona Tweedy, and I work in data governance mostly these days. And that means that it's my job to try and organize data so that people can get more use out of it. Also thinking about things like security and privacy and other laws that govern how we use data, trying to help companies and organizations set up policies to meet their compliance obligations there. But really the heart of it is, how do we organize this data in such a way that people can get the best value out of it, and people who want to do clever, amazing analytics are able to do that. Because, as you would know, in any situation in life, if you want to make anything, having your tools in order and knowing where to find the stuff that you want to use is a really important first step.
I love this topic because it seems so obvious. You just think, well, obviously you structure your data and it's, you make sure it's easy to use. But in actual practice, it's so rarely done. The number of data sets I've encountered that are just chaotic and deranged and really impossible to analyze in some cases, and in other cases just really, really difficult, because it's very easy to collect enormous amounts of data, but to actually think about how you're going to organize it and how you're going to make it usable in future, it's not something we teach, and it's not something we do instinctively, I think. So it's really important and really neglected.
I think that's very true. I think that, there are so many ways we can collect data now, and people get incredibly excited about all the cool things they can do, depending on their discipline, of course. If they're going to survey lots of people, or if they're going to put sensors all over a building, but they do get really excited about that collection phase. And of course, the use bit, getting your hands on the data and doing the analytics and producing some beautiful visuals is a lot of fun. But thinking about those usability issues up front, people don't really talk about it. And it's not the easiest thing to teach. In my data career, one of the tools I've taught is Omeka, which is an open source tool that was originally developed for little galleries and libraries to be able to create online exhibitions of their collections. But I was offering that as a tool at University of Melbourne for particularly HASS researchers who had collections of documents and images and things, as a way of organizing those, and actually figuring out how to teach metadata effectively was quite complicated. And it took me a few goes to work out how to do that, and how to get people thinking that the use you can get out of your data later is really going to be affected by the way you organize it up front. And it's hard for people to imagine future use cases and future questions, but really trying to think about that organization stuff, the metadata, using standards to improve the interoperability of data so you can mix it up with other stuff from other places, is so important to really increasing the value and the usability of that data down the line.
Yeah, it's fundamental, but as you say, really taught and quite difficult to teach. Can you quickly give us an explanation of the term HASS for listeners who haven't heard it before?
Oh, sorry. Yeah, it's the one that's not STEM. So HASS HASS is humanities, arts, and social sciences. So I guess people talk a lot about the STEM disciplines being the science, technology, engineering, and maths. So HASS is the humanities arts side of, the sort of two big buckets of research disciplines.
I'm increasingly of the opinion that a lot of the really interesting data is in the HASS space, and it's really potentially much more difficult to work with in a systematic way. So it's skills we really need to be focusing on and thinking about and teaching.
Yeah, and I mean, there are people like librarians and archivists who are absolutely amazing information scientists, and have really thought about these questions of how you organize things and how you maximize discoverability. And I think their contribution is sometimes underestimated. But that is one discipline which has really thought about how you can organize information for as a gift to future generations.
I like that expression. That's great. What did you have to learn to do your job? What was missing from your formal education?
Well, my formal education, I did an undergrad with majors in ancient history and Latin, and then went on to do a PhD in ancient history. So I didn't think very much about data and information at the time. And there are things which I realize now would have made my life, even as a research student in history, much easier. So we didn't think very much about how we were organizing our information, and even something like version control. I think it would have been useful maybe if someone had pointed out to me that giving files consistent names and incrementing a number on the end, or just having some sort of a system, makes you so much less likely to send the wrong version to somebody.
Yep.
Because I have done that. But I think so I didn't think about those things like version control. I didn't think a whole lot about the best ways to organize information to make it easy for myself to find. And we had this document that the University of Sydney, where I was studying, sent out, called the 7 Steps to Completion for a research project. And it had obviously been written for really for researchers in the natural sciences, because it had this advice like, you finish your literature review, in your first 6 months, which is just not how. Well, yes, probably doesn't work for science, and certainly doesn't work for the humanities, where you're reading new stuff right up until the last minute.
Yep.
And and it talked about, how to organize your data, and, what data collection are you doing? And, my reaction was, what do you mean? I don't have data, I have books, go away. But of course I did have data. And so just thinking about are there ways in which I could have organized this information to be a bit more user-friendly down the line, I think would have been a benefit. I was lucky enough to get to go and do some field work in Italy, and I had a lot of photographs when I came back of various sites that I'd visited. But it turns out that as time goes past, one pile of Roman bricks starts to look a lot like another in the photo reel.
Yep.
And I hadn't documented which photos belong to which site. And as part of the process of importing my photos from my camera to my computer, the photo program overwrote all of the metadata that was in the camera. And so overwrote the dates. Yes, people always flinch when I tell this story. Overwrote those dates with the date of the import. So I couldn't even go, it was hard to go back and, I couldn't even match the dates to my travel itinerary. So the magic of metadata was something I really, I think would have been helpful to learn a bit more about. And just my subsequent career doing things like data governance and data analytics, I've often thought maybe if I'd done a unit of an information science type subject, or maybe database administration would have been really useful. Figuring out how databases work and how you can make data relate has been something that I've really needed to figure out. You know, what does it mean to have a primary key? What does it mean to have a foreign key? What does it mean to be able to join tables? Some of those questions, which seem very sort of abstract, but are actually very, I think, if you're going to work with data in any volume, are concepts that you need to understand. And I mean, one of the really useful units that I did do actually was symbolic logic, which I actually did as through the philosophy department. But if you've done a bit of symbolic logic, it meant that when I encountered programming languages, it made a lot more sense to me, because all of those concepts like ands, ors, and ifs and nots were already really familiar to me from doing that logic. And there's that point where philosophy and maths really intersect in that sort of formal logic space. And so that was a massive help to me. And I would, I think it would be really beneficial actually if everybody did that as a subject, just because it teaches you so much about how to organize thoughts and how to think about how information relates and how you construct a query. So yeah, more symbolic logic for everyone.
That's really interesting. I've never heard anyone recommend philosophy as a path to data science before, but it makes perfect sense to me when you talk about it like that. That I did symbolic logic from within a computer science degree, but to sort of step it back from the technology and think about the pure logic and reasoning part is super useful.
Yeah, and it can transfer to any programming language or concept that you want. But it's just getting that way of thinking into your head.
Yeah. I remember when I was teaching secondary school, we did an assignment around the time, it was a privacy assignment, it was around the time the government was trying to make laws about metadata and revealing that it had no idea what metadata actually was. It occurs to me perhaps we should step back for a second and go, well, what is metadata and why does it matter?
Metadata is the data about the data. Now, I think in his attempts to explain it, Senator Brandis described it as the envelope that goes around the data. Okay, so the metadata is the way in which you describe and organize your data. So it provides the context which lets you interpret the data. And one of the really important things about it, I think, is learning to use as much as possible standardized metadata. So there are loads of metadata standards out there for different things, but it means that if you can describe whatever you're talking about in a consistent way, then it makes your information comparable with other sources, and it makes it comprehensible to other people.
Yeah.
And metadata standards are designed, they can be very subject specific. One of the ones I've worked with quite a lot is Dublin Core, which came out of the GLAM sector. That's galleries, libraries, archives, and museums. And that's a way of describing objects in a collection. And so things like the author and the provenance and what something is made out of, and the date it was produced, and all of that sort of information, which when you've got, I don't know, a book or an artifact, it tells you about it.
That's really cool. And you can immediately see how that could be useful if you wanted to go, well, okay, where are all of the bronze items in the museum, or all of the things that come from this particular time period, or this particular artist?
Absolutely. And so having that data and having it organized in a consistent way means that you can query across your collection and ask those sorts of questions. And that was actually what I ended up doing when I was teaching Omeka and trying to get people to think about organizing information, was this exercise called Bag of Thingies, where I would put them into groups and just give them a pile of crap and say, sort it. And most times people would kind of shuffle it into two piles and then kind of look at me. And then I would ask them those sorts of questions. I was like, okay, can you find me the biggest thing? Can you find me all the blue things? Can you find me, all the things made out of natural materials? And, so the better you can organize those piles, and the more detail you can get in, the better the questions you can ask of your collection later.
That's awesome. I am totally nicking that. That's brilliant. I love that.
I did the exercise once with a bunch of archivists, and they, of course, being, that's their bread and butter, and they'd practically constructed a relational database out of pipe cleaners as part of the exercise. But generally, people shuffle it into a couple of piles, and they're like, now what?
Yeah, that's wonderful. I love that. I can see that going straight into the classroom when you're trying to teach kids this stuff, because we used to have such drama with kids submitting electronically, because you try to persuade them not to submit assignment.py for their Python code, because I was going to get 50 assignment.pys, and trying to persuade them to put their name and their class and the teacher, or the question number or whatever in the file name, and getting 50 kids to adhere to the same standard was almost impossible. So even getting people to think about the idea that there could be a standard and that you could do things in a systematic way would be, I think, a big step forward.
Well, yeah. And I mean, if it's submitting an assignment or a CV or a job application, I think it's a really helpful idea to put your name in the file name, just to help those recruiters to know who you are.
Yeah. Everything that makes their life easier is good news for you as the applicant. Is there one thing that you wish everybody knew about data? One thing that would change the world for you if everyone understood it?
That the answers you get out are only going to be as good as the data that you've got in the first place. People talk about data science, and everybody is terribly excited about AI at the moment. But if the underlying data is not of sufficient quality, it doesn't matter what shiny tools you throw at it, your results are going to be limited in their quality and their usefulness.
Oh, I really like that. That's something that I think is very poorly understood. The idea that we have all this data, we can extract amazing insights from it. It's like, well, how good is that data and how meaningful?
And I had a job. I was the one and only data scientist employed by the Australian Ballet, and they had a review by a consulting firm who'd said, "You have a lot of data. You should probably get someone to science that." And so they hired me, and none of us really quite knew what we were doing. And yeah, the problem was, I think, that they just hadn't, there was a real disconnect between their ambitions for the data and the sorts of questions that they wanted answered and the data that they had. I mean, they had a subscriber database. That was great. But then, they would say to me things like, how do we future-proof the business of ballet? I don't think that answer is not directly in your subscriber database. We're going to have to break that down. We're going to have to talk a bit more about what you want to know and what this data can tell you. And, they were quite averse to surveys and subscriber surveys. People don't love surveys, and you immediately have a bias in your sample that you get responses from people who like doing surveys. But it did mean that what they had was very thin.
Mm.
and the sorts of things which they would have liked to be able to do just weren't really possible. And I
Yeah.
think, now that I'm a bit more experienced, I could see that what they really needed to start with was a fundamental information management program.
Mm.
And I think in retrospect, maybe insisting on that, because they wanted to do some analysis on the success of their subscription sales program, and work out whether it was better to employ a third-party call center to do these sales, or whether in-house was more effective. And the CFO asked me to look into that. And one of the things I found was that for some reason, they had deleted the soft copies of the invoices that the call center had supplied to them, and then archived the hard copies. So they were in a box in a warehouse.
Oh, God.
Yeah, right? And so then, trying to do some analysis on the data that just wasn't there.
Mm-hmm.
And that the information about what it cost to run the internal call center was in one place, and this other information was in another place. And so even that work of trying to gather up enough information to be able to make a stab at an analysis took a long time. And it's a constant complaint of data professionals everywhere, is that they can't get the data that they need. And it's because I think people just haven't thought, what if we need this, what would we want to do with this? And so sending hard copies of invoices away to a warehouse was an absolutely reasonable thing for the accounting department to do, because in their world they'd finished with that stuff. But it's like, can we, the idea that is also information someone might want was kind of new to them.
Yeah, no, not the way things used to happen, or not the way things not the way people expected things to be done. Your comment early on about how can we future-proof ballet reminded me of the section in Hitchhiker's Guide to the Galaxy, where they ask this big computer to figure out the answer to life, the universe, and everything, and it turns out to be 42, and they're like, but that's useless. And the computer says, well, yes, I don't think you ever actually knew what the question was. So I think Douglas Adams may have foreseen the world of data science, because there seems to be an awful lot of 42 and not a lot of knowing what the question was.
Yeah, exactly. And people get terribly excited about this idea of the amazing insights that we're going to be able to generate, but I think without necessarily understanding what the question is or what they're hoping to find out,
and what questions the data set can actually reasonably answer. And it's one of the first things we look at when I teach data science, and it's something that doesn't appear to be in any curriculum anywhere. What can we actually get out of this data, rather than what do we want to get? They're not necessarily the same.
Yeah, and I think it can be a little deflating for students in a way to start with that question, because you're thinking about limitations, and you're suddenly saying, well, we'd like to know all of this stuff, but the data probably can't tell us that. But I think it's incredibly important to be honest about that, and not give people this false idea that they will be able to magic up answers if the data set simply doesn't support it.
Yeah, there does seem to be a lot of that in the data science industry. The idea that we can just magic up stuff, and it's magic, and give me some AI, give me some data science, magic things will happen. A little more skepticism and informed approach would be useful, I think. What are the worst data mistakes you've seen?
For an absolutely criminal use of data that still makes me incredibly cross, Robodebt in Australia. That was an appalling abuse of data. And one of the things which really came out of the Royal Commission's report was the fact that people had been doing things with data, and again, that the data quality simply didn't support. And this had a consequence of ruining people's lives. That the department responsible had in fact tried to engage a data science team, some external consultants, and said, "Can you AI this data for us?" And I think it was actually Data 61, and their response, which was the absolutely honest thing to say, was that your data is not robust enough for what you're hoping to do. We cannot, in good conscience, AI that data because it's just not up to it. And people talk about, people were talking about that program as, AI run wild and algorithms run wild. And it wasn't. It was just crummy data analysis of, insufficiently robust data.
People doing things they shouldn't have done.
Absolutely. And people not thinking about consequences, or people in positions of power refusing to listen to the consequences. I think one of the things that came out of the Royal Commission was that frontline staff were reporting these problems, and that higher ups were refusing to listen. But the fact that you just couldn't identify people sufficiently consistently across data sets, so people were getting debts which didn't belong to them because they happened to have a similar name to somebody else, or
wow.
Yeah, and in Australia there are some quite tough laws around what you can do with a tax file number and the ways in which you can use it. And a tax file number would have been a really good identifier to use for a program like this, but because of the laws, they didn't use that, and so they were reliant on other identifiers. And so just even trying to data match people across sets, that was done not terribly well. The fact that they were asking people to comment on things from years and years ago, when you're not even required in Australia as an individual to keep your tax records for more than 5 years, and yet people were being asked to account for, their wages from a casual job they had for 3 months for a longer time period. There was data abuses all the way down in that program.
Yeah, and it's difficult to know whether that was as much mistake as deliberate and willful misuse. But that is my next question. Have you ever seen data deliberately misused? Do you have a different example, or do we talk more about robo-debt?
I don't know how much of it was deliberate, but whether at what point someone said, I don't think the data is of sufficient quality for us to be confident in doing this. And I think thinking about thinking about consequences. That my work now, I think a lot about data ethics, and when people in my company have got a bright idea for something they would like to do with data, one of the things I get to do is sit down with them and say, okay, what's the worst thing that could possibly happen? Who are the most vulnerable people who might be affected, and what does that look like for them? And happily, the work that we do is fairly low stakes, and so it's unlikely that anything really terrible is going to happen. But the higher the stakes, if you're raising debts against people, you really do have to be confident that you're right. If you're making decisions. Sorry.
I was just going to say that is one of the things that we don't typically teach when we teach with textbook examples and textbook data sets that don't have these kind of implications, which is why I like to get the kids doing real projects, so that you can actually, in the evaluation phase, go who is helped by this and who is harmed.
Absolutely. And textbooks, they give you these beautiful clean data sets for a reason, that they want you to focus on the analysis, and trying to clean up a messy spreadsheet is less fun if you're just wanting to teach the analysis. But as you've always emphasized, data comes from the real world, and it's messy stuff, and you've kind of got to confront that.
Yeah. How do you spot deliberate misuses of data? What do you look for?
I think, as you said at the beginning, or earlier, being a bit skeptical, and that asking those questions about who's benefiting, who paid for this, is a question to ask. That asking questions about where data came from, what data was collected, what's the, if it's a claim about a population, what was the sampling like, when was this done, I think are useful questions to start asking. There was when I was in primary school, a magazine published an article saying that left-handeds don't live as long as right-handeds, which was, distressing news to the left-handeds. And it turned out that the study was actually of US baseball players, which is a very specific population. And there are maybe some other variables which contribute to how long baseball players live. And so, for a bunch of Australian primary school students to extrapolate that to themselves and start worrying,
That's really interesting, because I hear that bandied about all the time, with, particularly having a couple of left-handers in my immediate family, and I keep hearing that stat. I didn't realize it was so very specific.
Then there may be
not
other
representative.
Studies. There may be other studies, but this particular one was of baseballers. So
I'm gonna have to go look now. What's the first question you ask when you look at graphs in the media?
I want to see the axes, and I want to see the scale. Are the axes labeled? Do they start at 0, or do they start somewhere else? What scale are we using? Are the scale on the X and Y axes comparable? Is this an appropriate form of visualization for the data? Everybody loves
that one.
When you get a line graph which bobbles up and down, but it's not, but the data isn't actually a series. It can be very misleading, because it implies a relationship, that something is happening, when, if the data is categorical, then no, it's just not actually a feature of the data. And you should have a bar graph in my opinion, in a situation like that.
Can you explain the difference between the data being in a series and the data being categorical?
Yeah, so data being categorical means that it's you can sort the characteristic into buckets, I guess. So you might have a data set that's about pet ownership in Melbourne, and your categories are going to be cats, dogs, birds, fish, sugar gliders.
Sugar gliders.
Whatever people are keeping. And each of those, and those are types of animals, those are categories. Whereas series data is something like time or temperature. So if we can have a graph that shows temperature during the day, and our x-axis is going to be the time of day, and we'll put temperature on the y-axis, and the resulting line, we can see that it starts cooler in the morning, and then it goes up, and then it cools off again in the evening. And it's meaningful to put a line there, because time is something that's continuous, and so we're looking at change over time. Whereas if we're going to graph pets kept in Melbourne, each of those categories of animal is distinct, and so I think we should put those into columns, and we can see that there are more cats than fish being kept.
Mm.
And to use a line graph there and join up those points, I think can imply a relationship or a change that isn't actually there. It's not like the number of cats and the number of fish is influencing each other. Well, it might be, but uh,
Not like that.
yeah, generally it's not that. There's not a relationship between those categories, and I think it's important that you use an appropriate type of visualization. So you're not implying a relationship that doesn't exist in the data. I mean, similarly, everybody loves to bag pie graphs, but pie graphs are useful for showing, if you've only got a couple of categories, they can show proportion quite nicely. You can say that, we can present that 2/3 of survey respondents think X and 1/3 of them think Y, and that's something you can show quite nicely in a pie graph. But again, if it's not about proportion, if we were to put that that pet data into a pie graph, for instance, I don't think it would be as useful, because it's not like there's a zero-sum game happening here, and that the number of cats influences the number of dogs. It's not that you can have one or the other. It's some people have both. So it's not as useful. So thinking about, is this the right type of graph? Have you labeled your axes? Are you telling me what's going on? What's the scale? Because we've seen quite famous examples of where someone is deliberately trying to exaggerate a feature of data, and they don't start the axis at 0, or they sometimes even break the axis, or break the count, in order to make a difference look much bigger or much smaller than it really is. And so those are the sorts of things that I want to look at with a graph, and then also thinking about, where did that data even come from?
And one thing that constantly worries me with those, particularly with axes issues, is that a lot of those issues are exacerbated by the defaults in various software packages, that you just get by default. Most graphing software gives you the range of the data on the y-axis rather than starting from 0. So if the data is sort of from 98 to 104, it'll look like there's big differences between 97 and 99 and 101 look very different. Whereas if you start from 0, they you can see that actually they're all quite similar. So the defaults are a problem, and I think that's that's part of the education process around data science. As what are the appropriate defaults, and should you just be accepting the defaults from your software, or do you need to actually think more about the message that you're trying to convey with this data, and is it meaningful, or are you giving a distorted sense of how your data really looks?
I think it's really important to think about what are you trying to tell people with a graph, and what's the question, and what are you showing them? And sometimes I think people are quite deliberate about a distortion, but
What excites you about data?
That's a great question. What excites me is how powerful it can be, and the stuff you can do with it, and the way in which, I really came to data. I was working in policy for the Office of the Australian Information Commissioner back in the heady days of Kevin 07 and Government 2.0. And there was a big push on then to open up more government data, that public sector collects huge amounts of information, and the argument was made, rightly I think, that if this is collected with public money, it's public property and people should have access to it. Health data and things notwithstanding. But so it was, that message really resonated with me, and I was incredibly excited by this idea that by putting information like raw data into people's hands, that they could make things and find out things and really be able to be much more informed about the world in which they live. I was involved for some years with the Open Knowledge Foundation, and they talk about a vision for a world where information benefits the many. And that's really what I love about data, is that its potential to sort of democratize access to information.
That's
and
just the
to
word I
enable
was
people
thinking of.
to enable people to ask questions and to hopefully hold powerful people to account, to be able to call out some of the obfuscations and not entirely true statements that come from our leaders in politics and business.
Yeah. Yeah, I love that idea that, claims get made and we can actually investigate the truth of those claims and go back and look and go, well, hang on a minute. And it was the great thing in some ways during COVID. A lot of the data that we had was open and immediately open. So the case numbers that we collected for all of the issues around what was collected and how it was collected and all of those things, what information we did have for the most part was available that day or the next day. And that I found that really interesting as a potential for the future. So, well, what if we did that all the time? What if we made this stuff really open and gave people the capacity to look for themselves?
Yeah, and it meant that the conversations we were having were based off, hopefully, the same information. That if we had an agreed source of truth on COVID case numbers, for instance, that sometimes I think our public conversations end up kind of going past each other because people are looking at different sources of information and prioritizing different things. But at least if we have a common data set, we can argue about how to interpret it, but we should hopefully be talking about the same thing.
Yeah. Yeah. That's awesome. Thank you so much. This has been a wonderful conversation, and there's so many bits that I think I'm going to be stealing and putting in my workshop. So pointing people to, you should listen to this. Yeah, it was super interesting.
Oh, well, thank you. It's been a lot of fun. And I mean, data governance is not a topic that gets a lot of love. People switch off when they hear it. But it really makes a huge amount of difference to what you're able to do with data, and not just avoiding big regulator fines.
Yes, there's what can you do, what are you allowed to do, and what should you do, and they don't necessarily line up.
Yeah, those are all interesting axes to explore. But if the data is crap, then then the can is very limited.
Yes. Yeah, it's a really important message. Thank you so much.
Thank you, Linda.
Thanks for listening to Make Me Data Literate. If you'd like to support the work of the Australian Data Science Education Institute, you can donate at givenow.com.au/ADSEI or via the ADSEI website. Let's change the world together.